and the different websites, okay, in the presentation. So, all right. Okay, so what is 3D printing? I like to use the example of you're a robot. You can do very precise small movements, and you have a glue gun. Okay, so if you haven't seen 3D printing, by all means, come up and look at this. When we first got this, I watched it. I sort of mesmerized watching it laid down layer and layer. But again, back to the robot controlled glue gun analogy, it lays down layer by layer, forms layers of plastic. At least this FDM printer does like that. You can use plastic filament, which comes in reels like this. It's literally, almost like a really thick fishing line. Okay, that gets melted and then extruded or squirted out, if you will, by layer in this type of 3D printing. There are others. You can use resins if you've ever done the gel nails and they cure it underneath the light. There's actually 3D printers that use UV cured resins. We won't talk about those today. Those are higher end. They're more expensive. They're stinky because there's lots of chemicals. So that's not really that accessible. So, and 3D printers have to start with the design, a digital design. Yeah, they have to start with that, and we'll go through that. So, oh, good. That's blocked on my screen, but not there. So
that's me.
That's her. She's always messing things up.
And all the business.
So why print? Why 3D print assistive technology? So there's custom things, and you'll see a few of those today that we can make with 3D printing that just don't exist on the market. Wheelchair brackets. I've worked with wheelchairs for about over 10 years now, and there's a lot of different brackets that are needed, and everyone's got unique needs. And I've done a lot of different things with wheelchair mounts and mounting lights on wheelchairs and leg bag emptiers with 3D printing that otherwise would have been a lot harder. Mount switches, unique key guards. And then essentially, the micro light switch, $95. This is my version of that, which costs less than $10. I'm still working to finalize this design, but it uses the same micro switch as a mouse. And that switch probably costs 50 cents to $1. Okay. So $95 for a micro light switch. I'm just like, why? I've actually torn one apart, and I know the exact part number, but even the part number there, the part that they use is more expensive than it needs to be. When I finish that design, I'll definitely post it on that resource sheet. So it can be very cost effective. If you're familiar with the concept of prototyping, 3D printing allows you, when you're designing something custom, to quickly print it and see if it fits, see if it works. I'll talk about this thing on the end here, what we did yesterday.
Sorry, making one change for people online can.
So fast prototyping and 3D printing. I don't think I have this in the presentation. 3D printing can actually allow you to create things that otherwise could not be created via like machining or mold making. It can print a little more complex shapes. All right. So, oh, come on, you got to see the jump roping sieve.
So while we're waiting for that to come up, prime example of that is you have a young man employed in Walmart, and they have a stacking wand, but he used a stacking wand, but he didn't know what to do with it. And yet that's what he needs to straighten the shelves with. He'd stick it in the cart, someone would say, oh, an empty cart, take it or something. Anyways, so he was about ready to get fired. And so we came and identified the problem that he needed something to put a stacking wand in. So I talked to Tom. Tom makes this bracket. And then all of a sudden we decide this wand handle is about this big. And so when we put it in there and we put a little magnet in there, and then he could just have a stacking wand with him when he was using his hands, put it right next to his chair. And so it just solved the problem. He has his thing at his employment that he was trying at and succeeded. So those are some of the things that Tom's talking about, thinking outside the box.
So, yes, if you don't get it, this is the simpler jumping rope. Thank you, AI image generators. I had fun putting some of those images in there. So why do I say it's fun? And I'm hoping that you catch some of the possibilities here. So 2 days ago, Tuesday mid-morning, I started working on this project. We have the metal parts to this, but literally nothing else existed. So I'm gonna, hopefully I can display this to you. It won't let me see the top of my screen. Okay, here we go. Hopefully it will show. Okay, so this is the design I started. There's 1, 2, 3, 4 different pieces. So I'm not trying to brag. I want to show you how quickly things can be made if you got some basic level of skill. So this part looks like this part right here. Just took a couple of minutes to design. Those two pieces probably took 15 minutes to print. This is the part underneath that large part on the center rail, you know, and then this is the arm trough. If you're familiar with the guided hands thing, that's basically our version of that. They cost like $50 worth of materials instead of this 629. Okay. So to make the point about, you know, cost effective, 3D printed.
Big forearms.
Yep. 8 cans of tuna spinach. And then we're going to come up with some future designs to mount on the front of this. It's kind of got a little people shipping. So anyway, so that's kind of the possibility, and that didn't exist 2 days ago, not in our world anyway. So let's see if we can get back to where I was. Of course, it won't let me. Okay.
Are you not able to play that as a video?
It wasn't. I don't have a video yet. Okay. So yeah, that's pretty cool seeing something on a screen and then an hour or two later it exists, which is it's really cool. So what are the possibilities? Now, there's a lot of photos that I'm going to show you here, and I'll give you very brief descriptions of what they are. So in general, writing aids and grips are pretty, there's gobs of designs for these online. And I'll show you some of the websites, but a lot of different grips. And we've got some here printed so that you can try out. But yeah, there's a lot. This is, you could probably guess, it's very similar to the writing dove. So I think it's a little better because the top flexes. So you're not, you know, so there's no, you don't have to physically lift that up. You know, different guides and everything. Those are typically pretty simple to print as well. Adaptive switches. This is the interact switch. This is a small switch, the very first one I think on the end that I did. This is a sip and puff switch. So I took 2 pressure switches and put them in line. So this sip and puff switch probably costs around $60. Of course, probably more now because we did that 3 or 4 years ago. But 3 switches, yeah, switches are pretty. There's a ton of designs for switches online as well. Adaptive gaming. There's a lot of pre-existing files for different knob attachments for different joysticks and keypads. It's a foot pedal. It's 3D printed. Jay, did you bring that yesterday? The Xbox controller with the. No, it's. But anyway, that's another possibility with adaptive gaming. ADL stuff, you know, scissors. I've got my version of a bigger scissors, a pill popper. You know, that's a tremor, you know, that rotates right there. Ed, do you want to talk about this?
Like this, we were doing an assessment for an individual and all they had to do is back, it was, what are they called? The
Mod pizza?
mod pizza.
And cakes?
It's, yeah, like the hosted ding dongs or
Ding
whatever.
dongs, yeah.
But then she had to wrap them and she didn't have the
In-
skills to
in
really
foil.
do it easily. So Tom came up with this little thing so she could put it right there, put the foil down and press it down, and then kind of wraps for her, so she doesn't have to spend a whole lot of time. It made it a lot easier.
It was a one-hand thing.
I'm sorry, I
So she
stepped
could-
one out.
You know, guide, put the foil down, centered it, and just push that down. Yeah. Task list. You know, we've got a few of those. I've actually worked with one of the districts and made some little custom, task trackers and stuff like that. These are a whole lot better than, I don't know if anybody's here that received those. Yeah, we have a lot better ability to design and print now than we did, what was it, 2 years ago?
That was fast. I saw this, I said, Tom, this is exactly what I need. My wife keeps telling me I need to stay on task. And so I take it home and I say, just put some things on here and I'll mark them off. So what does she do? Clean out the garage. Clean up the basement. I was like, no, I cooked dinner or something, but no, she put all the hard ones, so it wasn't very fun.
Oh, honeydew list for your. Okay, some wheelchair modifications and parts. This is a bracket for an anti-tipper. Right there on the back of the wheelchair. It's kind of hard to see, but this is a kind of a goalpost type knob. Tons of designs for wheelchair joystick knobs. This is a project that Jay and I worked on. This is, what do they call it? Anti-gravity arms.
And for a toddler who had a mitochondrial issue and had very, very, very low tolerance to RPS gravity. So we designed kind of gantry system that use rubber bands to make her arms basically.
Yeah, little silicone rubber bands there to provide some lift for those, so she can move it laterally and a little bit. I don't know if you see that. This is a brackets on wheelchairs. This is the Mogo mount, the flexible steel mount with the what's the photographic connector? Forget the brand name, but yeah, that's quick connect. This is a bracket right here that I made to move it on me. This is a power articulated tray for this guy. That's his MacBook right there. He's moving on me. So anyway, but the brackets to receive the posts that hold that whole assembly are 3D printed. And actually they're really tough because they were very dense. These are leg bag emptiers. They're solenoid valves that were mounted on power chairs. And the brackets to hold those in place. If you had to fabricate those from scratch without 3D printing, not only would it look pretty crazy, but it would be very hard to do. But with 3D printing, you can do it very quickly, and it looks like, you know, an 8th grader didn't, you know, or an 8-year-old didn't make it with, you know, with Legos and stuff. So there's a lot of different. Go ahead.
Sturdy wise. You know, how, like, when you're making those brackets, that really goes very much, how long does it hold up? Or do you have to replace them?
Tom? Will you repeat that question for the?
So the question, and let me know if I don't rephrase it correctly. So the question is, how sturdy are the different brackets and things that are 3D printed, right? So it depends on the quality of the design. And then ultimately, a lot of what you see that's 3D printed is somewhat hollow. So you can, and they call it percent infill. You think about it, it makes sense. You know, how much of the inside is filled, you know, is full. So if you bump that number up, you could actually go to 100% infill and something's very solid. I didn't bring any other filaments, but there's different types of filaments that you can use that have better qualities for the specific application too. This printer will do it's polycarbonate. I think it's combined with PLA, and I created some brackets for a different wheelchair. And I literally I would be able to crush them into the standard material. But that polycarbonate I couldn't, and I was floored. So it depends on the quality of design, how well it's designed, and how dense it is, and then the material.
I was wondering, so with wheelchairs, you have to be putting precise, sizing and stuff, kind of like a scaling tool, or how do you get it to fit the wheelchair exactly?
Calipers and 3D design. Yeah. How to design something? That would be like a 3-hour class, So, I'll talk a little bit later about what's called Tinkercad. It's software that you've heard of AutoCAD, same company, Autodesk. It's software that's geared toward like junior high, middle school, and high school kind of STEM students to get into design. And that's where I started. Not that I'm an expert, but that's where I would start. Because scanning, when I first started, scan things and then just print them. Yeah, not yet. We're not to that point of a replicator in Star Trek. I know that's not the thing. Did you have a question? No. Oh, okay. All right, I did not repeat that question. Sorry about that. Okay. So there are multiple types of 3D printing. We're basically not going to talk about most of them. This is FDM. We'll talk a little bit about more. This is the type of printing that we're going to focus on. This is the resin. I talked to you about it. And then this goes tens of thousands of dollars. You can literally print in metal now, process called sintering. So of the whole big picture, and then this doesn't even include their 3D printing houses now. Concrete is extruded out. You've probably seen that. They're claiming they 3D print food, which is just extruded, which they've done for decades. I don't know why they're calling it 3D printed, but it's just a paste of some sort that's squirted out in the shape, But I guess it's cooler to call it 3D printing. So again, back to the analogy of the robotic controlled. Yes, thank you, AI image generator, Mike. It's good. It's easy to think about it. If you look in here, what you'll see is a very small nozzle that is not unlike a glue gun nozzle moving around. It'll do one layer at a time. The thinner the layer, the greater the detail. If that makes sense. So it's literally melted. It feeds from this, makes it all the way in. It's melted, extruded, layer by layer. These 1 kilogram, 2.2 pound spools are very common. Multiple colors. We talked a little bit about the different materials are possible as well. So the overall process with 3D printing, you have your design. You either find one that's shared, and there's a ton of designs online. We'll go into that a little bit. There are a ton of designs online readily available, or you can create the design from scratch. You have to what's called slice the file. So this speaks a language that is not a 3D design. It has to turn into, mostly it's G code is what they call it, that controls machines. So you have to, we call it slice, where you take that image file and basically adapt it so that the 3D printer can interpret that. You also do change settings, and then you print. And I always think it's kind of a weird thing to call it printing. I don't know what else I would call it, but yeah, it's more extrusion. But anyway, so digital files. So these are the three most common. And you don't have to write this down; it's in the resource sheet. But there's the QR code for that. The three big ones, in my mind anyway, are the Thingiverse. I think that's probably been around the longest. Principles. The Ultimaker is, they used to be really big, but they're not nearly as big. I think their website's bigger than their 3D printing company is. Principles is by Prusa. Prusa is, I think, a Czech company. Make really good quality printers. They have their own file sharing website, and then Maker World is by Bamboo. They're pretty good sites. There are other sites listed on the resource sheet, but by and large, they search files from those websites. There's AT specific shared files. Now, Maker, anybody heard of Makers Making Change? So they're a nonprofit out of Canada. And what they do, their model is they have these basic designs for different things. Some of these here are their designs. They link makers, geeks that make things with people that have needs. And those people that have needs might, they need to pay $10 for an adaptive switch. So they're the network, so to speak. There is technically a network in Utah. A guy from UATP and Logan and I are technically the reps, but I don't have time to do their PR events every month. But that's a phenomenal resource for basically what I would consider homebrew assistive technology. Okay.
And for example, how that might help you guys, if you see a student in your class that needs something specifically made, but you don't know how to make it or what to do, you could take pictures and then you could write up what you want it to do. And then you could reach out to one of these resources, and then these other people can try to develop it for you, and then they send you the program, or they may print it for you and then send you the product. Is that?
You did that. I did that. The force is strong.
Yes. But anyway, so that's the nice thing about a lot of these other resources that are out there.
Okay, so this is going a little slower than I'd hoped, but design files, if you're interested in doing design yourself and you're not familiar with it, Tinkercad, I think, is great. Especially if you've got good spatial ability to visualize things. I was able to, when I started with Tinkercad, in 10-15 minutes, I was starting to make ugly designs, but I was making stuff nonetheless. Again, it's geared toward, secondary students. What Autodesk wants to do is kind of hook people in with free software. And then if you upgrade to Fusion, it's like Fusion 360 is like $2,500 a year or whatever. But, if you get a high schooler hooked on it, then I guess you have a customer for life or something. But I use Onshape. Onshape is a fully powered 3D design. I started with Tinkercad, but I just was reaching limits with it. What I showed you earlier was Onshape. It is free, but you have to share all of your designs. And what I do is I name them really crazy things so that people can't steal my designs. You call it Fluffer Nutter, and it's low force, adaptive switch or whatever, something like that. SolidWorks for Makers, another full function 3D design, 25 to 50 bucks a year. Blender is also free, and these aren't all. There's a lot of 3D design software. I think it's more artistic. It's more for organic shapes, and we tend to have more practical things. I think it's less intuitive, but that's just me. I couldn't really wrap my head around that. But anyway, questions about 3D design?
Blender did more out like movies.
I know that does like 3D rendering and stuff. Yeah.
Blender also uses 3D models to render for a variety of purposes.
Yeah. Yeah. There's a YouTuber, 3D printing professor, and his big thing is Blender, and I'm like, I just don't see the. Yeah, I don't see the connection, but I threw it in there. I think it might be too, the way I think is not geared well for Blender. I tried and tried. I think it might work for other people, which is why I threw it on here. Yeah. So, yep. All right. Printers. We can spend hours and hours on this. And I think this is timely, and I hope at least to some of you, this at least piques your interest, because the way that this brand of printer prints rocked the whole 3D printed market about 2 years ago. Some of the big players in 3D printing manufacturing had to, double back and kind of, like Ultimaker I mentioned earlier. Yeah, they're blown out of the water. Not only is it cheaper, it's almost a plug and play level simplicity. We've had 2 other printers at UCAT, and literally this is running well over 95% of the time. The other printers, it was great if it was 60% of the time. And that's a quantum level difference. So it's easier to use and it just works. It also has, and obviously this is not a paid presentation, but I think especially in your districts, if you've got this level of capability, you don't have to tinker with it as much. This right here, this combo, I think is around 1,500. And that's that top one, X1C. This one with the combination is, it's on the resource sheet. I think it's a P1S. And I think that's around 700 to 800 right now. If that's what I was, if I was in a district and I was pushing for a 3D printer, that's the one I would go for. If you can't get the 1,500, great, but you'll get the same print quality and a lot of the same functionality as this. And then let me go ahead and, I haven't looked at it. Let's hope it printed well. So this is what was printing at the beginning of the session here. It's about 22 minutes. And it can actually do that a lot faster. Why?
And then I didn't realize the popularity of this printer. This couple of weeks ago, I went down to St. George. My wife and I, we like to go to the farmer's market. But this year when we were down there, there was about 6 or 7 tables set up. And they had all these little toys and all these little different things printed. And I was just like, and I said, I went up and I asked them about how they're doing it, and they wouldn't give their secrets. And I says, you used the bamboo, didn't you? Because that's what we have. I don't know nothing about printing. And they said, yeah. And I says, no wonder. And they said, it's the only thing to use. It's so easy. Just drop the file in and it prints. So it was really an eye opener because they have hundreds of toys that they've printed, and they're like snakes that actually bend and all entwined, and little monsters that have little legs that move. And the nice thing about it is, give it to a kid, they destroy it, print another one. That's the nice thing about it.
So I don't want to spend a ton of time on the different printers. The second choice that I would recommend would be Prusa printers. I've used basically knockoff versions of Prusa. They're a very, and I've spoken with a lot of people that are more knowledgeable of 3D printing than me. They're very consistent. Their quality is good. They're expensive. To get this version, and this is what they came out after Bamboo came out with this printer. This is their Prusa XL it can now also handle multiple filaments. This is about $3,000. It's actually more if you include all the head changers. A little bit different, but I mean, yeah, it's more expensive. The quality is pretty darn good though. They have great support and parts, and there's a really strong online community for that brand as well. I'm not really going to talk about other brands, but anyway. All right, so let's change gears.
Yeah, the buttons.
Okay, soldering. Who's soldered before? Okay, is it hard? Yeah, it can be finicky, but why are we going to talk about soldering? It's going to, especially in terms of switches, it's going to open up really open up this world. It's not hard to print the 3D switches, but I think if you haven't soldered before, that might be a barrier. So, yeah, we're going to, so there are tutorials on the resource sheet if you'd like. They don't have a lot of them, but you know, there's tons of tutorials online. Yeah, or you can, you know, you have someone else teach you. That's probably, you know, depending on your learning style, that might work well for you. Or you can have somebody else solder it for you. But anyway, uh-huh.
Can you repeat that question?
Yeah. The question is, would UCAT be willing to repair switches that are broken? Yeah. If you want, yeah. You want to send it to us, we could. Yep. Yep.
A reasonable amount.
Yeah. Yeah.
Somebody brought me like 20 and they didn't even know if they worked. I was like,
yes, we can provide a course on soldering.
got the video
Yeah, we've got a little video that's coming up. So the interact switch.
in a long time.
Yep. Do you want to go ahead and pass out the kits?
Yeah, I can.
Would you like some help there?
Yeah, sure. So we are going to, you too can make the switch. So you're going to assemble one of these interact switches. Yeah. Right now, whether you want to or not. Oops, let's see.
I don't think you have
Okay. Yeah, there's three. Yeah. That was it. So there's 24 switches. I'm hoping there's enough for everyone. If not, find a partner. We'll go through. So the tutorial starts you from scratch. And what Ed Wesson has done is basically, you know, 2/3 already assembled this for you. What I'm going to do right now is show you. So this is regarding soldering. So don't worry about it. We'll give you some more information
In just a sec.
going forward. But
this is the key point you need to remember. And when you do it on your own, there's a little hole here and you need to stick it through the hole first before you solder the switch. I am not a fast learner, so 3 of them I had to redo to hurry and then with soldering, but that has to go through that little hole first before you solder the switch normally. These are all done for you because we figured we wouldn't have time to solder. So you guys just need to put on the
show them the switches.
This,
The micro switches.
oh, yes, yeah, I have them.
Yeah, I like them to see that before the.
And so this is what a micro switch looks like. That's what's in your switch there. And the way that you can figure out, if you don't have a voltmeter, you can get one, or conduit T or whatever.
Continuity, yeah.
Continuity, that word too. And so I'll hold this up so they can see this part. So the nice thing about it, so there's different ways. So if I did this without even pushing the button, it would work. So if you have someone that you just wanted something to work and then stop, like
you wanted them to turn it off.
If they didn't like that music, then they could press the thing, and as long as they held it, it'd be off and then it comes back on. Or you can wire it with these two. So now, oh, no, I was wrong. With these two, so every time you press it,
So there's 3 pins on the bottom of this micro switch.
yes.
And what he did first is he put the tester probes on the outer tube, which means it's
It's making it
always
current.
on, and then push the switch, turns it off. The second tube, it turns it off. Or sorry, it turns it on when you push the button.
Yeah.
So the 3 pins allow you to do different things.
And so that you guys would have control if you build your own switches of how you wanted it to activate. So you just need to know when you wire and solder, it's usually I found the 2 pins that are underneath the button, but that's not always.
Yeah, yep. So this is a video showing Ed. Oh, we're not getting audio.
That's probably a good thing.
Where's that little, take that little speaker. and take that.
Shoot.
Okay.
Well, Ed, do you want to narrate, Ed?
I'll just explain.
Just narrate.
Okay, so we thread it through, as I told you, slow learner, but that's the most important part. Comes through. It's chopping.
It's some,
And then, gosh, when you put lights on your hands, it makes you look like you're really old.
Please soak and come on.
Yeah, I need to, obviously. And then,
So those are the pins.
and those are the pins that I was describing. And on your switch, you want to make sure when this goes in, it's going to be in the center where the button is. This metal part, if you notice, I ripped that off. It's talking.
Yeah, it can't be heard overhead.
Oh, okay.
So this is
So then soldering, and you notice with the soldering, you get it, both sides of the thing, you clean it off, and then if you load the solder, it is hotter than if just putting the iron to it, and then you put it on the back side, and then the solder will draw in to it and make a good connection.
the video linked on the resource.
And it's,
Sorry, it's so
yeah,
choppy, you
it-
can't
it-
hear the
it's
audio.
very simple. The reason why we use these is they hold it, of course, but they also act as a heat sink. Because you're applying a hot iron to the switch, and if the switch gets too hot, it'll burn it up. But this will act as a heat sink and make it so that the switch isn't hot while you're soldering.
Sorry, the video's not
Hey,
what you,
you're
so.
doing the best with what he had to work with, so what can I say?
Yep.
It was much better than this before. But
Yep.
anyways, you can get cheap solder irons off of Amazon. This was a very inexpensive one.
That's a $10 one, and I actually really like it.
And yeah,
Temperature control on too.
versus is $100 soldering iron. But I think actually $200 soldering iron. But anyways, it's soldering the temperature. If you go about 360, that's a good temperature, but it's very simple. Don't get people get the big solder. Oh, I'm getting a good deal here, but that's the big solder for stained glass. Get this little stuff that has flex, and it'll heat faster and transfer heat quicker. So that's that. And you can always watch the video. The video will work on your computers. But anyways,
So these are the pieces you have in front of you, the different parts. The little piece of tape, there's 3 small screws in there. If one of the parts breaks, don't worry, we have some spares. So again, this is that micro switch at the center. This is maybe a 60-cent switch. So the cable, the cord itself, the cable's probably, the way we bought them, they're probably $1.50, 60 cents for the micro switch, and then 50 cents worth of plastic. Question? Everything else. Yep. Yep. Yeah, we can't 3D print wire. But yeah, that happens. That's a good point, though. There's a lot of projects that say they're 3D printed. Like technically a 3D printer can replicate itself. No, it can't. Typically, it's 3D printing with other parts and components.
and then there's little testers you can make too, or you can buy, just so you can test your toys or whatever, your switches that you have to see if they're working or not. Sometimes they'll draw you.
So
the batteries.
So grab the 3-prong thing right now. Okay, okay, so
It's gonna go into these.
so put one of those, so you see there's a little there's five little lines on the arm that should be pointing up. So you want that hole, if you will, the opening on that switch is basically upside down. So put one in. It should be a pretty tight fit. So yeah, push that first tab in. And then don't wait for the third one because you can snap these pretty simply. And then once you've got that first tab in, push a second tab in. You may have different colors, that's fine. Okay. There's a little, the third tab is a little trickier. Is everybody there? Can we move forward? A cap? Okay, so the third one, put your index finger underneath, and then with your thumb kind of bend that third tab. And then kind of let that third tab into the hole. Okay?
I was gonna say, don't get your finger in there.
Yeah, don't remove your finger. Yeah.
You might need that for later.
So as you hold that, when you push on that little, X thing, it should give you just a little bit of bounce, a little bit of resistance there. That's actually what gives the switch its play. It's called a flexure device.
Thank you. Thank you.
Okay, everybody there? Anybody have issues with this? Getting to that third tab? I see some. Anybody need help? If you need help, raise your hand.
Maybe in the back edge. To the left. Oh, they got it.
You got it? Okay, moving forward, grab the cap holder. Okay, it also has 3 flat tabs on it. So slide that in one of the spaces where it goes, like there. Once you do that, gently squeeze it and then push the second tab in and then the third. This is a lot simpler than the other one. So you should be able to turn it now what really is right side up and nothing should fall out.
Do we need to break the little things here?
Yeah. Yeah. Yeah, there's little printing. Yes. Yeah. Yeah. That. Yeah. Some of them might have a little
Excess on there. Do I have to take it off?
Anybody help with that? Raise your hand.
This side, Tom, maybe.
For what? You good on that step? Okay. I don't want to leave you behind, so if you have an issue, raise your hand. Okay. So yeah, now get that, make sure you have that third tab in. Okay, so if you look at now what you've got, that assembly, you'll notice 4 corresponding holes in the base. All right. So this can get a little tricky. Does everyone have a screwdriver? Okay, so take the screws out of the tank and thread them in the bottom of the switch base. Do you smell? Okay. Yeah, it's right there on the base. Yeah. And if you don't get this finished here, we can always, help you after, but we'd like to send you home with a switch. So. Okay, so once you have those threaded in. Yeah. So you see these holes. What? Oh, okay. All right. Okay, so you should see this right here. You can see my cursor moving. That's what the base should look like. Okay. with, with the screws sticking up through the base, okay? We have some extra screws, or if any of the parts are broken, let us know. We've got extras. Yeah, you've got a screw loose, raise your hand. I got plenty. So as you can imagine, you're going to line up the top with those screws. Now do it one screw at a time. So, you know, it kind of takes some ability, but you need to hold that assembly together, line one screw up, partially tighten one screw. When you've got one screw in place, move to the second one. Don't just crank all the way down on the first one. Yeah, you'll make it a lot harder. Your screws might fall out of the base, but welcome to my world.
That's normal.
Yeah, everybody's got a screw loose sometime. What's that?
The one making the most contact is the one first.
Yep, the one that aligns the best. Yep.
Pretending that I know what I'm doing.
Hey, they can tell you big one.
Exactly.
So again, partially tighten one. When you get one partially tightened, align the second one, partially tighten it. And then when you've got two, go to the third. But again, partially tighten them. If you crank all the way down, chances are you're going to twist and break that cap holder. And it might be harder to align with the other screw. This is kind of a trick to assemble things when you've got multiple screws in two parts. Don't crank down on the first one. You want to align everything before you really tighten it. Okay, so when you get does everybody have 3 screws connected? Or are we still working on it? Okay, raise your hand if you need help. Okay. Yeah, exactly. Okay, screws. And screws. Hey. Anyone else needs help starting the screws?
What is this called?
Micro switch.
Okay,
There's hundreds of types.
you're good.
Yeah. You need help? Okay. So if you've connected all 3 of those screws, slowly tighten it until that you do it one screw at a time, slowly tighten it. Everything's even, and then you'll get a crisper action. This is what you should end up with. Okay? So the cap's really not sloppy. Right now, if you haven't tightened it down, if you do this, it kind of rattles. Okay? But you want, again, don't tighten one more than the other. Just tighten them sequentially, partially, until you get all of them tightened up. But there should be no dead zones. Should be able to push it anywhere. Okay? And there's your $50 switch. Honestly, we've built so many of these, it takes me like 4 minutes to put one of these together. It's not bad at all. Oh, do you need some help?
I was gonna say, ask your neighbor, but she looks pretty busy.
I would do a bit after these two.
Well, then you're better than you were when you woke up, right?
Hey, that's something information you can take home.
Yeah, I'm so fun.
First. Yes, yeah. So you can loosen it, so you can back those screws out. You know, let them kind of. So again, this is a $5 foot fish. Depending on where you buy the table, that's really the biggest thing. Okay, well, we're good. Need some help.
Somebody's happy.
Yeah, we got it. Okay. So.
Alguien más.
Okay.
Hey, but that's for playtime.
Yeah.
I'm sure. Look who used a screwdriver.
You probably just drink the screwdrivers, huh? You know. That needs to be tightened, I can see it. It's floppy, it needs to be tightened. If it's tough. I know. I would tighten it a little more.
Yeah, mine was that way.
Knuckle dragger to help tighten it. Yeah, there you go. Sorry, man. Okay. It worked. What's it doing?
It's a little too heavy.
A little too happy. I don't like happy. Something. I need something scary or louder. I don't know. Is this one like on squeezy right now? Oh, there you go.
So we're told that the. Yeah.
Oh, my goodness.
So we.
I know the name.
This has 11 different items. And they're sequentially placed on the table like that. So you start on your right hand side. Please, I was hoping for more time, basically have play around with stuff, ask questions about it. So by all means, feel free to go look at the devices. We have a lot of different writing aids. You can actually try it out. Be careful with the scissors because they're longer.
So as we want to thank both Ed and Tom for all they've done for this session. Thank you so much. Thank you. Thank you, Gift.